present a case study. So we were looking at City of Goleta. It's one of the cities in our county, and so this is kind of what we're using to kind of evaluate the system and see what we needed to do. And then finally, I will talk about future work with respect to this project, and also what we want to do with this project, because eventually we don't want to just kind of keep it within our office. We kind of want to share a lot of the tools that we're developing, so that maybe other offices can use our tools. Let me start. Okay, so next slide. All right, so essentially the process that we're doing is we got to import and join our data shapefiles. We got to clean them. We got to do feature engineering, which is a lot of stuff that we don't have necessarily in our data, or sometimes we have stuff in our data, but we need to code it in very specific ways so that we can insert it into a statistical model. And so then we set up a statistical model. So in our case, we're going to be using a linear regression. And then ideally, you want some type of interactive platform. So it's not just me that, has to use the code, but then it could be our appraisers or someone else. And then obviously you want that platform to be able to analyze the results and then make a decision. And so what's important here is that ideally you would want one platform to kind of be able to do everything that I've described here. And obviously it won't be able to do everything because there's some specialized tools that you might have to use for certain things. But in general, what I like about the platform we have is that, I mean, if our GIS files weren't shaped in a GDB, I would never even have to open ArcGIS to do what I'm doing. Like I could do everything outside of there and very efficiently and very cleanly. And if I needed to change something, I wouldn't have to dig through like 20 different drop-down menus to change something. I can just insert a line of code that is very interpretable and boom. So R is the data first statistics language. So that's great because like things like Python, they call it the best second language for a reason. It's just very flexible and everything it can do, but it's not meant to analyze data. And so this is one of the big advantages ours has. So the other thing is that because a lot of data science, a lot of people use this, it has a tremendous amount of libraries that are just available for free, vetted. There's published papers that'll give you all the details about this, about all the tools they use. And then there's Tidyverse, which is kind of this framework that makes everything work compatible. So 10 years ago, R was a huge pain to use because if you wanted to use one package, you weren't sure if it was going to work with a different package. But that issue has kind of been solved with this collection of packages that are compatible with this. And then if you want to make your app, or if you want to make an app and display it on the web, we now have this thing called Shiny, which lets you use all these, allows you to make these websites and stuff that are interactive very easily. Like, and then there's a lot of GIS integration. So there's a package called SF that you can do a lot of basic things. So if you're doing buffers, joins, you can do this with a line of code and you'll be done faster than, trying to open ArcGIS Pro. Like I seriously try to avoid it. It's just so much faster to do a lot of these things here. But if you want to use ArcGIS functionality, there is a package that allows you to connect to ArcGIS Pro. And I mainly use it just because we have very specific information stored in a GDB. And Esri, essentially, this is how they kind of keep you locked in, is that they won't let you write to a GDB without having an ArcGIS Pro license. And so if it wasn't for that, there would be very little use. And so another good thing about R is that you can use other languages inside it. So SQL, whatever database you have that are using to store your appraisal data, you probably can write the actual language within your scripts, or you can use these translated kind of syntax where you don't need to write SQL. So as you'll see later, I work from we store our data in an SQL database, and I have 0 lines of SQL code in it, which is amazing, because sometimes it gets very tedious to write these things, but there's better ways. And it's so easy that like I can show my code to non-code experts and they will understand almost immediately. I've worked with appraisers that have no serious background in programming, and they kind of look at the code and they say, oh, I get it. And so, yeah, and then Python is an important thing because a lot of modern interfaces are based on Python, but that's not an issue because now we can use Python inside of R. And so for tools, I use RStudio. There's an open source version that's free, desktop version, and there's a server version. So if you want to do your work on a server, it's possible. There's also professional licenses. And if you're working with Microsoft products, there's Visual Studio, and they have varying degrees of their versions all the way up to the enterprise system. And in that sense, you would be using their tools, and you would just get an R extension in order to do a lot more things like visualize sometimes like the graphs you produce or whatnot. It, excuse me, it supports that. So I'm going to talk about previous work we did. So we were doing so this spring we were doing a Section 51 analysis, and we were trying to figure out if there was any areas that would qualify for a reduction in housing values. So I coded this thing up in R, and we kind of came up with an algorithm that followed current or existing practices in this office. And so we were tasked to finding valid and robust, statistically significant results. So we had to be very, very sure that these properties experience a substantial reduction in house value because of market trends. And so what happened is we ended up finding about 14 book and pages where there was properties that we saw significant reductions there, and we suggested to our deputies 5 to 10% reductions in them, but none of them were accepted. And the problem was that the spatial scale was too large. And so they were like, well, you're working on book and page, there could be many different types of communities there. And so they didn't want to move forward with any reduction. So we went back to the drawing board and decided to try other tools that would maybe address these concerns. So what we did, I've been working on is a regression model for the city of Goleta. So we have our adjusted sales price as the variable we want to predict. And then we have a couple of variables that we included initially. And this is an ongoing project, so we're still kind of testing new things and whatnot. But this is just to give you an idea of kind of what the base model looks like. And so one thing we did is to include spatial data. We kind of partitioned the city up into all these neighborhoods because we found that being in a certain neighborhood actually there's some relation between the price and the neighborhood you're in, obviously, but it's actually not true for all neighborhoods, but it's definitely true for some. And so with linear regressions, what will happen is just, if it's not a significant factor, then the contribution from being in that neighborhood will essentially be minimal, and so this is one great thing about this approach, is that it does let us get more granular. And so here's kind of what our workflow looks like. We just connect to an Esri GDB to grab our tax parcel information, the spatial tax parcel information, so our boundaries. We have a Microsoft SQL database that stores all our property characteristics. And then what I do is I essentially use R all the way to do everything from cleaning, joining shape files, running the code, and then analyzing the results. And so before I show you our results, I kind of want to give you an idea of what this code looks like, because it's pretty easy compared to what it used to be. And so what I'm doing is I'm just saying, okay, we're going to make a function that tells us when something, what dates we're interested in. We're going to connect to our database. And this is literally this, and this code is all I need to do to connect to my database. I just have to tell it its name, what my username is, and what the name of the table is. That's it. There's no SQL, no complex IT, like I just got the names of the tables I needed and that's it. No views. And since I'm not writing to it, everything I'm writing is all going to be local. So there's no need for like extensive IT involvement. And so here, what I do, filter, I just say, hey, here are the columns I have. Here's the characteristics I want. And then boom, give me that database. And the reason I did it this way was just so that I don't have to download all the data all at the same time. I just focus on the data that I want. And what I could do is I could also move these characteristics up here so that, say, an appraiser can say, oh, well, I want to look at mobile homes, I want to look at condominiums, but here I just hard coded it. And so then after this, I just do things like cleaning the data, building the assessor numbers from there, and then I calculate, I do some mathematical transformations for some of our variables because that's what regressions need. And then I fix some of our discrete variables. So the way it's stored in our database is not very amenable to regression. So I just fixed this and this is it. It's, yeah, it's a bit of code, but this is all I have to do to just set up my data. So then I go to my main script and this is where I call it. So then I just say get the database and then the dates I'm interested in. And this function here is what's checking to see that I have an ArcGIS Pro license, because these lines of code is how I read my shapefiles in. I just say, give me the GDB, give me the layer that is at this position. And then here I turn it into a table that that can be read and manipulated in our regressions. And so, yeah, so I just read two things in from Esri, and let me clear everything because I'm going to run everything from scratch to show you how fast it is and how this is pretty much the thing that takes the longest to do is read in my data. And so I read a separate file from Galita, and then here's where I join my my data frame with all the property characteristics and my shapefiles, and then that's it. And then this is just all my model. This is just getting the results. This is actually the regression right here. And so let me just run it. And so I erased everything. Everything's from scratch. So it'll be a couple seconds because reading the shapefiles are actually the slowest process. So there you go. So I already ran a regression for that we would use in Gamma, and then this is how we visualize our results. So here it tells me what my coefficients are in my linear regression. Here are the, you know, how significant each of the coefficients are and how much of the variance is explained by my model, which is 90%, which is really, really high. And then I can see what my errors kind of are. And you can see here, my maximum error is about 16%, 15%. But, oh my gosh, we're sorry. We have a test emergency right now.
Yes, I had got the message. This is a national test. All cell phones are receiving the national alert. It's not an emergency, it's just a test. It should be calming down. My phone
is this the nationwide one?
Yeah.
Okay.
Yeah, Eastern
time.
11:18.
All right.
Okay.
Sorry about
Everybody's
that.
getting it right now.
Okay.
No, we're not trying to get out of your presentation.
Okay, sorry. Okay, so then, yeah, so then when I ran that regression model, so all I had to do is I had to give it, well, what's my data? What's the formula I used? And these are all just columns in my data set. So I'm trying to predict this variable, and then these are all the variables that I want to include. And so then this is what the results that were spit out. It kind of said, okay, this is the relationship between, the effective year and the price, the adjusted price, and all types of different variables. And then as you can see here, again, these are my maximum errors on both sides. And I think in order to do automatic enrollment, you have to be within 5% of what you think the market value is. So in this case, this model got 60% of all entries between 5%. So one thing I'm doing is essentially trying to work on further narrowing my maximum error and having more properties fall into that into this 5% band, because then it makes our appraisers' lives very, very easy. And yeah, so that's about it. It's like I said, it's very simple, very fast, this code. There's a lot of instruction here where you just like, I understand we have model builder here tools, and what I kind of find a lot of times is it just slows us down. If I need to change something, add a new variable, it will wreck a lot of the model builder workflows, whereas here I can just kind of append something along the way and much easier to see. Like, I don't have to open 20 script. I mean, I have 2 scripts, but that's it. Like, everything I need to see is there. Yeah. So in the future, what we want to do is include additional variables, because again, we want to have higher prediction capabilities. And the other thing is that the process I'm using right now is actually kind of antiquated, in the sense that we have tools now that will automatically, like, you can say, okay, clear out any columns that have, missing entries, or rows that have missing entries, clean out columns that all have kind of the same value, because that will mess up your regression. And you can store these as quote unquote recipes. And you can reuse these recipes over and over again with different data sets. And so I actually started working on it. I couldn't finish it, but there's just a lot of things that you could just automate, all your pre-processing, and it's literally one line of code. So in my earlier code, where I had to do like all these things here, I could have written this in one line of code. Like, this could have been all turned into like way fewer lines of code, and they're very easy to kind of know what's going on and so forth. So this can be further improved. And then another thing is automate variable selection. So one thing is that there isn't kind of a uniform model that would be correct to use for all of the county, because we have North County, Santa Maria, and then we have South County, which is like Santa Barbara, Carpinteria. It would not be right to use the same regression model for both of these things, but then that would mean that we'd have to process things differently. But that's no longer an issue, because the machine learning community has built so many tools that will help you kind of select which columns you're going to need in order to maximize your prediction capabilities. So, and then on top of that, yeah, there's more advanced frameworks that we can use, and we just haven't gotten there. We just gotten started, but yeah, we're really excited with these initial results, that very, very basic variables. And yeah, if we had our data stored in a say a Postgres GIS, I wouldn't even need Esri products, and my code would be probably 5 times faster. So yeah, and then one other thing we want to work on is, I don't, it's not fun for an appraiser to be working on stuff like this. So one thing I want to do is build a interface that's reactive where appraisers can hard code or they can enter their own values so that, you know, if they want to focus on certain cities, certain property types, they can just enter in values and then it would filter their data set in the way they want it, and then it would run an analysis according to what they're doing. And so the closest thing I found to, oh man, I closed it. There is this Shiny app, they call it, where it allows you to essentially have like a web-based application that that allows you to allows users to enter the profiles. And I don't know where it went, but I'm so sorry, but it's pretty awesome. And so the last thing is we want to make our code more generic at some point and share it, because we understand that not every county or not everything uses the same database schemas. Some people might have different names for their columns and stuff. So what I want to do is reprogram it so it can be very generic, and that you know, if a different county wants to find it, they can find the corresponding columns and use those. But essentially it'll be the same information. And what's cool is that you know, we have a pretty standardized process in appraise, so we probably are collecting the same characteristics, but again, sometimes the names might change. And so this is something that could be handled pretty easily within R, because I can just say, okay, this is a column variable, and then at the beginning of your code, you just put the column variable that your agency, your office is using, and then the code should work the same. And then the next thing is we want to start a GitHub repo where we can upload our code and then update it collaboratively. So it's not just our office that would be updating it, but other offices would be able to also chip into this code and make it better. So yeah, and this obviously free of charge, because all the tools we're using are open source, and they they um, they are free if you are, I think government and like academia falls under their bigger uses. So yeah, this is it. And so if anyone has any questions, I would be more than happy to answer them. Thank you.
Thank you, Carlos. I don't think you said what actual system is your county using for your property data?
We just have a SQL database where we're storing our database, and we update it using something called APS, which is also developed in-house. But for my end, since I'm in mapping, I'm just reading our database. They gave me the address of the server. They gave me the table it's in, and that's it. I just wrote like 6 lines of code that grabs that data, and I can work with it. So I don't have to create views. I don't have to do anything really complicated. I just need an address and I read it. It creates a file here locally. And the way I structured my data, I don't download the data as soon as I kind of call it. I wait until I do all these filtering so that I'm only collecting the data I'm going to use at the end. Because what you don't want is to have everything being transmitted over your network all the time. Because especially if you have a lot of APN, like we have 130,000, which is not too bad. But if you have more than that, you might want to reduce the scope of what data you're going to need so that you can have it on your desktop almost instantly. But yeah, there's a lot of databases this stuff has been programmed for. Yeah, I haven't really, like, all the main popular database services are covered, and even some more niche type of databases, you can easily connect to them with the same 6 lines of code I wrote there.
Wow. Lynn, you had a question or comment?
Yes, I have a question. So, one says, how did you count, for the price of property location first? So
Yeah.
how, in your model, how do you consider the location factor? Do you use just neighborhood, or you use XY, like longitude? That's one like a factor. The other factor, school, like especially high school, like those top high school, maybe they're
Yeah.
only one street apart. They make big difference in the price.
Yeah.
So how did you consider these two factors?
Oh, that's very easy. So what we did for neighborhoods is we have a shapefile. Oh, sorry. We have the shapefile where it's like, okay, every lot within this. And so what it does is we're building a column for every neighborhood. That's a 1 if you're inside this neighborhood, 0 if you're not. And so the same logic can be applied to school districts, anything you can think of. And so, for instance, we know that in Montecito, there's a certain, one of the areas in unincorporated areas in our county, one school district we know for sure has, that being in that school district affects the price. So all I have to do is make a layer that indicates that this property is in that district, and that's it. It'll consider it. It'll factor it in there. It's very trivial issue to work with.
My next question, I saw the R square is 60%. So in how it's the result align with the reality with the how the accuracy, I mean in practice how it's.
Well, the kind of perspective on it, so we don't have like a economics type of where, there's a causal thing where you have to, like, this is more of a kind of machine learning approach where we have these variables and we're trying to predict what they are. And what is challenging at times, it's like, wait, why doesn't this variable make sense? But what happens is that there are all these complex interactions kind of happening in the background that we might not necessarily understand. It might not be intuitive, we'll say. So what we see is like, oh man, I think at some point we saw that the newer your home is, the lower your property values are gonna, and it's like, well, why does that make sense? And it's like, oh wait, it could be that we have all these really high-end properties in older areas of the city, so Montecito and stuff. And so it would be very difficult to kind of say that we could understand it without really kind of looking at the really broad picture. So I kind of hesitate to give an interpretation just because it's complicated. There's a lot of interactions that, we'd have to think through in order to kind of defend this. But the most important thing is, well, we have these adjusted sales prices that serve as a benchmark to see, well, how close is our model getting to this? And if we can show that, we're doing a really good job at predicting these prices, then, does it matter? Probably not. So, but the whole point too is this is not to give every property a price. This is to make sure that we kind of can exclude all these properties that are very kind of easy to predict. There will be a lot of properties that are not going to make sense. And so we hope that those are way fewer in between and that an appraiser would look at them, because otherwise you're just enrolling kind of the market price, the sales price. So that's very hard to kind of argue against if you just bought a house. So
Thank
so
you.
yeah. Mhm.
Thank you.
Philip, you have a question? Philip,
Hi, yes. Quick question. Have you used, or do you feel comfortable using statistical modeling with what you have right now for assessment appeals in terms of like comps and valuations? Or is that something that you plan on doing in the future?
So So at some point, we do want to find, build a comp builder for our appraisers so that they can find what properties are most similar, because that's one thing I learned that they spend a lot of time on. And so, excuse me, there are different models that we can use, but right now the priority I've been given is to work on a mass appraisal that will let us essentially do automatic enrollment for properties that are that are around market, where their sell price is likely to be the market price. But yeah, that is one project we kind of started working on, and it's a little more different, but yeah, yeah, I feel comfortable doing this. A lot of my doctoral work taught me a lot of these techniques that are very useful here. I work with time series data actually, but I can also work with the data we would find in an assessor's database.
Right. Thank you.
And Matt, you have a question.
So following kind of to the previous question there, do you anticipate in kind of showing appraisers or other staff or mapping out, if you will, what variables you do find important, and is that something that you would consider?
Yeah, well, the thing is that certain variables might be important at certain times and at certain places. So, it might be that, some neighborhood is really hot this year and next year, maybe not so much. And so, I mean, when they get our results, they'll see what features were found to be important. And one thing we can do is say, okay, well, what happens if we take out all the ones that are not useful or something? We could definitely do that, no problem, just rerunning it. But in general, you kind of want to include everything in there just because you don't really know how different variables kind of interact with each other. And as you get more variables, the number of interactions between variables grow exponentially. And yeah, and they also change. So if you run this regression in the first 90 days of the year, they might be different in the last 90 days. So I would be a little hesitant to kind of say, well, this is what matters. Well, because what we'll find is like, this is what mattered here and at this time. It's not, I doubt it's a very universal thing. And if it is, the degree that it affects the prices might change. So.
Cool, thank you.
Any other questions or comments? So I think one thing that we can all see from what's been presented this morning is mapping is not drawing with pen and ink on Mylar anymore. A lot of claps for your presentation there, Carlos. I think that it's definitely showing us a new potential world. Oops, not getting what I want. I had created a poll and I'm going to launch it now. I'm curious. We have seen such high level presentations. I'm wondering where everybody is in their mapping journey. So if everybody would pick one, if you have something that does not fit any of these categories, if you put it into the chat, then we'll get a better idea of where everybody is, and it's something that probably we should have asked before. I didn't allow multiple answers. I know some counties were still hand drawing if they didn't have it in a digital form. So we've got 54 responses. I can't read. And the mapping looks like is mostly being done in CAD with GIS. Rin uses AutoCAD, but mainly RX Spotlight. I'm not familiar with RX Spotlight. So that would be in AutoCAD or other CAD, I'm assuming. So very interesting. We are getting mostly CAD. Some people are using GIS, Parcel Fabric, geodatabases.
Oh. Let me close. Oops. Yeah, let me stop sharing. Oops.
So that's interesting to me. When I started here 23 years ago, I actually had been using AutoCAD, and when they handed me pen and ink for my drafting test, I was a bit shocked. But GIS is becoming the predominant system, either with CAD or on its own. So very good, very good. I think we may have to look at having our meetings with the CAAIT conference, because we're seeing that we're not that far away from them in many ways. Not all of us are at Carlos and Rebecca's level of development. I'm very fortunate to have my IT people to help me with that kind of stuff. Let's see, San Diego has a hybrid approach with most maps drawn in AutoCAD and line work amended in Parcel Fabric. Very interesting. So we're just at 11:40 now. We had talked about if it was possible to move the afternoon up a little bit. Unfortunately, as I mentioned earlier, our last presentation by ProWest, they are attending another conference, and it worked out well because there's, I think, a 2-hour time difference. So their conference will be over and they can come and join us. So with that, does anybody else have anything they'd like to discuss at this point, or shall we move on to a very nice long lunch break? Which, since we're in offices, probably won't be all lunch, but there you go. I can only do so much for you. Teams has not allowed us yet to provide lunch with a virtual conference, unfortunately. So I'm going to leave open the meeting. So whenever you get back, if you want to discuss with somebody, you're welcome to stay on and visit. And I will, I believe, okay, Bonnie, look instead of guessing. 1:40 is our next presentation. It says 1:40 a.m. That was going to be a long presentation. It's just a typo. EagleView will be presenting about their product. And so until 1:40, enjoy your lunch and a nice long rest from all of this talking.